Welcome to the new session of our subject, Geology for Civil Engineers. And today we are going to discuss about the topic mass movements. So what we are going to discuss today, we are going to see that what are these different kind of land movements and how is it happening. And we'll see that some of the major parameters which controlling the mass movement. And then we'll see that how we can prevent happening of this kind of problems. So a mass movement called a comprehensive term. Mass wasting is a comprehensive term representing all the downslope movement of material under gravity. So that is a simple term, and there are a number of different varieties of mass wastings. And if you see this, what are the major classification of mass wasting? There are based on three different parameters we classify it. First one, it is based on the rate of movement. It is either slowest, then increasing the velocity, then the fastest. Or some of the mass movements are very slow in such a way that it moves 1 centimeter in an year, or 1 millimeter, 2 millimeter in an year. So such kind of slow movements are there. So that usually happens in some kind of slopes. We may not be visibly see, we may not be able to see the movement of material from the surface. But after a period of time, for example, even if it is 2 centimeter per year, then once the 10 years which passes, it becomes 20 centimeter movement. And if you can imagine, you are constructing a building or a residential building or a factory, and you are having some underground pipelines, and your pipelines is going to drag 20 centimeter in 10 years, then that is not a civil engineer or anybody would appreciate, or anybody would want to happen. Okay, so that is not possible. That is not what we can afford. So we need to take precautions, so that movement we should avoid. Other than there are second type of classification, if you see that there is depending upon the material, type of material which moves, so we can call it as a debris flow, air flow, or a mud flow. Debris means that is predominantly by coarse grain materials, larger sediments, larger 2 centimeter, 3 centimeter, or larger sediments. Then if the material is completely finer grained, we call it as an earth material, for air flows. And if it is the material is saturated with water, it is having high content of water, clay and silt. These are all fine. Clay and silt is fine grain materials. Like clay, you know that we make the potteries using the clay. So that kind of clay materials, if it is saturated, we call it as a mud flows or a mud. And based on the type of movement, it is either a flow where the entire things flows down slope movement like a viscous fluid. And second one, it is a sliding, when the material slide down movement in a relatively intact. So the material which moving, that may not be disturbed. But in the case of flow, the entire material is disturbed. But in the case of sliding, there would be a plane through which the entire things slide. So in the contact may be affected, but the material which is moving may not be intact, may be intact. So that's what we call it as a sliding movements. And the falling movements, it is a free fall or bouncing from a cliff or something like that. So this kind of different, whatever we have seen in the video right now, mostly they were flowings, that is moving downslope as a viscous fluid. And the most things what you have seen in the video, which were by the saturation of the water. So water gets saturated, and finally the surface layer of the earth which completely flow like water. That is what we have mostly seen in the previous video. Okay, so these are the basic ways we can classify. And if you summarize all these classifications together, so we can say that the type of mass movements, which is either a slow mass movement, which is a slowest mass movement, or a increasing velocity, and there may be a fast one. So there are three types we can classify. This you have already seen. There are flows, slides, or falls. So these flows, which are, as I just discussed, the flow which are moving downward as a viscous fluid, as a completely viscous fluid, it flows down. So that we classify it into a character, that is creep. That becomes a slow movement. Then that will become a earth flow that increases the speed. Then in the mud flow, then very fast it is a debris avalanche or rock avalanche. So the bedrock, if it moves, we call it as a rock avalanche, and if the debris or the loose material which moves in a very fast way, we call it as a debris avalanche. Then slide, we have seen that the material would be moving and there would be a plane through which the material slides now. So there are different types. So there are which are debris slide or earth slide. That is depending on the size of the materials, what it moves down. Then the rock slides. Rock slides is a complete rock which slides down. And the fall, which is rock falls. Basically from a hilly terrain, the rock falls down and it get into the slope and moves down when very quickly. We call it as a rock fall. So all these terminologies together, we roughly say it as a landslides. Mostly we will be hearing the term landslides, and we may not in newspapers and all. If you read, you may not classify the mass movements into any other term, but we'll say it as a landslide. That is a general term what we usually use. But as of a civil engineer, we should know that there are different varieties of movements which happen. So what we are going to see is that there are few common type of these movements, mass movements, that we are going to discuss. So first one, we call it as a flowage. So this is a downgrade movement of mass along no definite plane. So it is flowing in a viscous medium. So that is what we have just discussed. For example, if you see here, the entire mass of this soil which flows down. Where is the breaking? Where is the failure planes? This is the failure. So through which it flows. So the material which is at this phase where it is, it may not be intact. Even you can see there is a tree. So that tree is not moving. So that it moves as a complete body where along the failure planes. Okay. So each grains behave as it has its own surface of shear failure. So that we call it as a flowage. Here in this second case, if you see, this is also the same thing, that is a flowage which happens, and to the front portion of the flow, we call it as a homoky toe. Okay, so it is a sliding portion. It is coming down, and we can see it here also. This is the homoky toe. This is another kind of failure. We call it as a solifluction and permafrost. What happens? The first stage there is in the winter. This is usually happens in the areas where it is ice covered. So the winter, the ice will cover the land. As a result, the soil or the water which is present in this portion, that also will get converted to ice. So this entire body is in the freezing temperature, which is the freezing zone. But during the winter or the summer, what happens? The ice on the surface will start melting and start flowing, and some layer of this part also get melted, and it will become water. And that below that there would be a portion that will still remain as a ice. So that portion we call it as a permafrost. So that part will remain as frost only, whereas the surface layers where it melt and it started flowing, so that will slowly started moving towards the downslope direction. So here in this case, here is a river. So the entire thing which are moving towards the river on the surface. Okay, so that process we call it as a solifluction and permafrost. Now this is a mud flow. We have seen some video. We have seen it in the video itself. This is a mud flow. This is a large amount of mud or fine materials which is flowing in the downward direction in a saturated manner. So this is again another kind of flow that we call it as a debris flow. Okay, so completely these materials which fall as a complete. We have seen that how do we classify the debris and the mud and the earth. This is because depending upon the material which is composed of. Okay, now there is another, that was all flow. There is another parameter, other type of downslope movement or the mass wasting. We call it as a creep. So creep is a very slow movement of the material towards the downslope direction. For example, if you see here, This is a soil, and this soil doesn't flow quickly. Rather, it flows very slowly. Okay, so if you see here the telephone post or the electric post, which you see here, it is tilted. It was suppose something like this. Now it is tilted, and this gravestones, what you see here, this is also tilted. So there is a wall that also got tilted. And if you see the rock type in this area, the surface rock also get tilted, and it is having a downslope movement. So such kind of movement, this is what we call it as a creep. So these creeps are basically by the action of water which is flowing on the surface, or by freezing and unfreezing of the surface. So these are the two things which happens, which produces this kind of slow movement. So if you see this area, unless and until you look carefully for all these indicators, nobody will be able to understand that this is a area which having a creep process or a mass wasting process. And without understanding this, if you construct a building here, and that building will also start moving slowly downward, and there is a pipeline which is connecting to this building. So sometimes we may find some stress which is accumulating on this pipeline, and it may break in a period of time because of the downslope movement of the material. So even if it is 2 millimeter per year or 3 millimeter per year, this may not be a suitable condition for the civil engineer. So there are processes we can stop this movement. We will discuss that later. But this is what we call it as a creep process. Now this creep process, these are some of the actual photographs of that the previous picture what I have shown. See, this is this surface. This is all vertical rocks. But if you see in the surface, the layer is slightly bending towards the downslope direction. And if you see the tree is taking a turn because of the surface soil movement. I said that there are different reasons. Now, one is with the water which flowing on the surface, and another one is just the freezing and decreasing of the surface soil. So, what happens when in the process of movement? So, if you imagine two grains are here, and when this when there is a period of freezing, then it slightly changes its position because of the size increases. You know that the when things get frozen, the volume increases. So that's minor slight change in the volume of the surface, or the changes in the volume of the material. So the material which is actually here in this part will slightly move up. Now in the deep freezing portion, then the things will come down to its original position. Now what happens because of the slope characteristics? The material which will not directly go to its original position, rather it will slightly slip to another position. Okay, so this is in the normal condition, and this is in the freeze condition. And after freezing, when it get back to the original position, the material initially was on this the position on the starting position was slightly moved, not very fast movement, but slightly moved towards the downward direction. So this downward directions continuously for a period of longer duration will move the materials towards the downflow direction. So this process we call it as a creep. Other than that, there are another kind of downslope mass wasting movement. We call it as a slide. So in slide, if you see, there are mainly three type of slides: transitional slides, rotational slides, or rock topplings. So in transitional slide, you can see that the material is having the surface is planar, and the speed is rapid, and falling may be rock slabs or debris, which moves it as in a straight wave. There is in a straight sliding movement. Whereas in the rotational movement, the falling surface is curved. Okay, so there is a slight rotation movement. Whereas in the case of rock toppling, the complete things will fall down completely. And there would be a complete change in the direction of the material which is moving. So that is called a rock toppling. So these are different kind of mass movements. Now, for example, we are seeing here it is a rock slide. This is a simple example. There is a river which flowing on the valley, and this is a valley. Okay, this is a hilly terrain, and this is the valley. So this is a hill. So if you see the rock type here, what happened? This is a clay bed. Clay means that the loose soft material by which we make the earth pots. And there is another rock type. We call it as a sandstone. Sandstone is a coarser sand size. Sand means what we use for the construction. The reti what we use for the construction, and the rock type which is made up of this is called a sandstone. Okay. So the clay bed is overlaid by a sandstone. Now, the movement of this sandstone towards the downward direction will produce a deposit on this part. So, this kind of deposits what it is produces. Okay, what happens here? The sandstone which was here, now it moved downward and it formed the valley. So, this actually produces a natural damming condition. So the water which was flowing here, now that becomes a lake. So this kind of conditions are very common in the case of Himalayan terrains, where large number of rivers are flowing through small valleys, and there would be number of landslides, and all these landslides may sometimes produce us lakes. And these lakes also, this will break also. I don't know whether you remember or not. A few years back, there were a large cloudburst in the Himalayan terrain, the Kedarnath. And if you remember that the cloudburst is a large amount of cloud which suddenly drops water. Okay, it's like you are pouring water from a bucket. So something like that, a large amount of water which came into the channel all of a sudden. And all these rivers which was flowing in this area, which got filled. And when it got filled, what happened? This kind of natural dams which was there on the river, which got broken. So as a result, all this lake stored water started flowing through the river in very quick way, and that damages number of small artificial dams, and that damages a lot of our construction things. Okay, so this kind of natural dams are common. These are produced by the landslides. So mapping and understanding these natural dams is very essential for a civil engineer to understand to predict that what can be happened in the future. So last type of one, it is called the rock falls. So as you are discussed, so there would be number of this I don't know whether you remember this. This is called a frost wedging. What was that frost wedging? The ice which enter into the cavity and exerts pressure on the rock, as a result which removes the material, and this is a type of weathering, the frost wedging. So what happens is the frost wedging, that is completely removing the rock and it is falling down, and it will come to the downward direction and the downslope direction. So we call it as a rock fall. And here in this case also, this is another situation where there is a sea wave which cutting the bottom portion. So this is a rock bed, and there is sea coming, and the sea started cutting the rock from this part because of the wave action. Okay, and when it cut, once one period will come, this portion will cut down, and this rock will fall down to the sea. So this kind of movement we call it as a rock falls. The fall, sudden movement, the large mass of superficial mass fails by moving as a wall along the definite plane. So this we call it as a fall. Now, if you see the summary of this mass movements, these are different parameters which controls the mass movement. Number one, it is the slope. Number two, it is the elevation or the height of the area. Number three, it is the thickness of the soil cover. Number four, it is the orientation of planes of weakness of the bedrock. Number five, it is the climate, whether it is ice in ground, water in soil, or debris, precipitation. And the last one, it is the vegetation. So if the slope, if you are taking up, the gentle slope or horizontal surfaces are mostly stable. Whereas if you go to a steep vertical region, that seems to be unstable, most unstable situations. Okay. So if the area is in low relief regions where we are mostly stable condition, and if the area becomes high relief, that is what the starting somebody was asking. If this all happens in the high altitude regions like Himalayan terrains or the hilly terrains. But as civil engineer, they are doing constructions in Himalayan terrains or the hilly terrains where we need to construct roads, we need to construct dams. Most of our dams are located in Himalaya. These all are constructed by civil engineers. And while constructing the dams, we have to reach the location, we have to construct the road, we have to carry material and went to the location. All these things, while doing all these things, we need to take care of the facts of the rock mass movements or the mass wasting. Okay, so thickness of the soil, if the thickness of the soil is slightly thickness, little small thickness, then that is usually the stable condition. But as the thickness increases, that becomes the unstable conditions. Okay. So orientation of the plane of weakness of the bedrock. So planes are right angle to the hillside slope. Or if the plane of weaknesses are right angle to the slope, then it is going to be a little bit stable condition. But if the planes are parallel to the slope, for example, if this is a hill, okay, and there is a weak plane, something like this, then this part is really unstable. But if the weak plane is something like this, then that doesn't make much difference. This is perpendicular to the slope, whereas this is parallel to this first case, what I have drawn is parallel to the slope. So that becomes a relatively unstable condition. Then the vegetation, highly vegetated area, which seems to be stable because the root which goes into the soil and it holds the entire soil from other movement activities. Okay, so that is one of the parameter, and where the area where there is no soil covered, then that area becomes relatively highly vulnerable for the mass movement activities. And the mass movements are usually triggered. There will be something which triggers this movement of the material. So it can be an earthquake. Small earthquake can create large landslides, and large landslides can create earthquakes also. There are landslide mass movement induced earthquakes, and earthquake can also create mass movements. So this works both the way. So weight added to upper part of the slope. For example, we are doing some constructions on the top. So we are adding some extra weight to the soil. So that creates a failure of the slope. Undercutting of the slopes. So if the civil engineer, when you are using a hilly terrain, a civil engineer they cut this part for the construction of a road. So this area becomes really unstable now. So undercutting, the cutting of the hillsides will create the trouble. So this can initiate the movement. So heavy rainfall. So if there is a heavy rainfall, all this water enter into this part, and there is no space for this to flow down. So it will start exerting pressure in the downward direction, and finally the entire soil along with the water will flow like a stream. So that will create the failure of the slope. So earth materials we have just discussed. This is again the topography what I just discussed. This actually happens when there is a slope. This is what actually happens when there is a material which is on the surface, and when the slope is gentle, the force which is acting, that is the gravity which is acting on this material, can be divided into shear force and the normal force. So when the slope increases, the direction of these are the two forces, shear forces and the normal forces. The direction of the forces which slowly moves towards the downward direction. So in third case, if you see, this is directly on the parallel to the slope direction. So that creates the movement. So as we say that the increase in the slope, if the slope increases, the risk of downslope movement also increases. Okay, so these are all different parameters what it controls the downslope movement. Vegetation, we have seen that if the area is having more vegetation, that means that becomes stable, and if the vegetation reduces, then that becomes more susceptible for the downslope movement. Water is also we have discussed, climate also we discussed. Then the last topic what we are interested to discuss here, that is that how we can monitor or control these downslope movements. Okay, first thing that whenever we do a construction on a hilly terrain where the slope is more than 45-degree angle, we need to check whether the area is under a downslope movement or not. Generally, in a general thumb rule, if the area is having more than 45 degrees Celsius slope, okay, so steeply sloping, and whenever we see, then it is more than 45-degree angle, the surface is, then just see that whether the area is in a downslope movement or not, or in a mass wasting or not. And if it is in the mass wasting, then we need to study the history of that area, how this area is affected in the past. Then we may go for some geotechnical characterization. Then we may take some preventive measures to avoid the future downslope movements. For example, this is a hilly terrain. Now, what the construction what we have done, this was a slope and this is a steeply sloping. Now, for the construction of a road, what we have did is that we cut all these things. Okay, now if you see this entire portion which is under a highly risky. Okay, so this kind of cuttings we should avoid as far as possible. Along with that, by constructing some buildings on the top, we increase the load. So this kind of things we should avoid. That is one thing what we can do. And if we are not able to avoid this kind of thing, then what we can do is that we can reduce the slope. It's like reduce the slope and provide some retention walls. Okay, construct some retention walls which will stabilize the slope, or do some kind of slope stabilization methods like bolting. Okay, so we'll come to that. Then another condition, this is what another cutting was made. The stability of the slope is now in question. Now water which is centering into this surface will start flowing through this part and it creates the area completely unstable. So what we can do is that to avoid this, providing a channel, okay, this kind of horizontal openings, water pump pipes, so that the water which is entering into this will flow to this part easily, so that there is no accumulation of water on this part. As a result, it will reduce the failure of the slope. This is another example. There is a concrete shed which is provided for this road to support the road, to avoid the failure of the road. So this kind of structures also can be produced. And in this case here, the construction of this road, see this road construction how completely reduces the stability of this slope. Now this is all dipping towards the road. So this is really a unsuitable condition. So this all part can slip down and the road, it can damage the road. So what we can do is that we can remove these materials, though excavate little more so that the stability we can increase. And if that kind of things are not possible in some situations, we go for, you can see this here, it is called the plates and bolt, rock bolt or rock anchorings. Okay, so these rocks which are here, they are now anchored. They are now anchored to the subsurface, the other layer, the bottom layer of the material. So this will help to stabilize the slopes. So any of these methods, any of this kind of method we should adopt while using a slope area for any kind of construction, and at least having an understanding that, okay, this kind of activities can happen in this area, that also will be helpful for a civil engineer to avoid any future problems.